Hello students, welcome back. In this video, we'll continue our discussion on a DQ operation on Q. We in the previous video we have seen the algorithm to perform the DQ operation. Right? So this was the algorithm which we discussed. When I am performing DQ operation, I'll first check is Q empty. If the Q is empty, I'll say that I cannot perform DQ operation because there is no element inside the queue. That's why it is an underflow, right? But if the queue is not empty, right, I will remove an element from the queue. I will remove an element from the queue, right? And then I'll check the element which I removed. Was it the only element in the queue, or there were more than one elements in the queue? If it was the only element in the queue obviously must have become empty. That's why I need to set f and r to -1. Else, that means if there are more than one elements, I'll simply increment f to f by 1. That is, f will store an index of the next location. Right? So that was the algorithm which we saw. Let's now implement this algorithm. So this is our main function. In main, I have created this queue object by using this struct queue data type, this x variable in which I'll be storing the value which I get or extract from the queue. So I'll call the isEmpty function before performing DQ operation. I'm performing the DQ operation. Before performing DQ operation, I'll check is the queue empty. Is empty and queue. I'm asking isEmpty function, hey, is empty. Is this queue empty? This isEmpty will check what is f. If f is -1, it will return 1, saying that yes, the queue is empty. If this function returns 1, that means this condition is true, right? And the queue is, I'll print the queue is empty, it's an underflow. Else, that means if isEmpty function returns 0, I'll execute else. 0 means when it will return 0, when the queue is not empty, that time isEmpty will return 0. If the queue is not empty, I'll perform DQ operation, right? So I'll call DQ function, and to this DQ, I'll simply pass my queue, and this DQ will remove an element from the queue, and it will return that element to me, and I'll store that element in X, and then I'll print that, right? So that's the flow in main, right? And then now let's see this DQ function, right? So let me take some bright color. So as this DQ is returning an integer value, the return type of DQ will be int DQ. And as you are passing an address of the queue, so I need a pointer here, right? Pointer p. And what should be the type of this pointer? What is the type of address you are passing? You are passing an address of the queue or struct queue type variable. So the pointer will be struct queue type, right? So this p is of struct queue type pointer. Okay. So now here in this DQ function, I'll not worry about whether the queue is empty or not, because I am calling DQ only after making sure that the queue is not empty, right? So here I need not worry whether the queue is empty or not. Here I'll just remove an element, right? Int x, right? I need a variable here. This is local variable of DQ. X is equal to, now I am so this is the situation. Now p is pointing to this queue, right? This is q, and p is pointing to this q. I have f here, I have r here, right? So I want to get an element if f is 2, r is, let's say, 4. So I should get an element from location 2 from data array, right? So I need to access the data array by using this p. So p arrow data, that means we are accessing the data array which is inside the structure pointed by p, right? So that's why p arrow data. And which location in data array? The f location, right? So I need to retrieve the value of f. I will not directly say f. I will not directly say f because this f is inside the structure pointed by p. If I want to get the value of f, I should say p arrow f, right? P arrow f, right? So this is like in this particular case, p arrow data of 2 because f is 2. So this p arrow f will give me the value of f, right? So I got the value of this element which is on f location. So right now, after getting that value, right, I'll check whether that was the only element present in the queue or there were more than one element, right? How will I check that? Simply I'll check the value of f and r. If they are same, the element which I just removed was the only element. If p arrow f is equal to p arrow r, if they are same, that means I just removed the only element in the queue. The queue must have become empty, so I should set f and r to -1, right? So I should say p arrow f equal to, this is assignment actually, this is assignment and this is equal to, this is comparison, this is assignment. P arrow f equal to or assign p arrow r equal to -1, right? If I remove the only element, I should do this. Else, that means there are more than one element because p arrow f and p arrow r are not same. In this case, what should I do? I will simply say p arrow f equal to p arrow f plus 1. I'll increment f. I'll increment f. F will become 3. I'll increment f, right? And after doing this, what will I do? I'll return this value which I retrieved from the queue. I'll say return x. Yeah, that's it. Very simple code, right? I'm calling dq, right, by passing the address, memory address of this queue. So this memory address will be stored in this pointer p. That means p is pointing to this, right? And if I want to access the contents of this structure by using this pointer, I should use the arrow operator. So I'll retrieve an element from the f location in this data array, right? And I'll store it in x. And after removing that element, I'll check, have I removed the only element? That means the element which I removed, was it the only element in the queue or was it the single element in the queue? So if I have done that, that means the queue has become empty. I'll set f and r to -1. Else, that means when there are more than one element, so I'll simply increment f, right? So and then I'll return x. So this is the simple DQ code, and I hope you might have understood this. So in the next video, we'll see the example of NQ and DQ together, right? So stay tuned and see you there. Thank you.